a mobile emoji.
Okay, I think we're live now. Let me just check.
Okay. Okay. Hello. Let me make sure my mic is also tuned up correctly. Yes, it looks like we are good.
Okay.
Can you hear me all right? All right,
Yep.
cool. I guess how many? I think I see one viewer here. I'm going to wait for another minute here.
Yeah, I think we can wait for a couple of minutes. Did we get someone to share the link as well on Twitter?
Hmm. I don't know. Okay, I see another viewer now. Hello. If you're in chat, please press 1. Type 1 in chat if you're in chat. Okay, 3 more people. 3 people watching now. I'm going to if you can hear, if you are in chat. Nice. Okay, cool. I guess I think some people dropped off. I think people can hear us. That's good. All right, cool. Let's get started. We're already you've got 1,000 pounds in Syria on Raul Paul's advice on X. That's nice. Okay, cool. Let's we're not here to talk about the price thing because it's too exciting. Let's talk about the Walrus Hall Hackathon. So welcome everyone. Thanks for joining for the second workshop for the Walrus online hackathon. So we went over how you can store and retrieve files on Walrus last time. And if you missed that workshop, please go rewatch the recording on YouTube. It's already there. You can rewatch it. You can pause it and analyze it however much you want. But this time we're going to go over Seal. So let's get started. So I'm going to show you how to use Walrus and Seal to build more interesting decentralized application here. So here is today's agenda. We're going to go over what is Seal, how do you encrypt things with Seal, and how do you decrypt it, and then the next steps on your journey to the Walrus Haulout Hackathon. So what is Seal? Well, Seal is a decentralized secret management protocol that leverages SWI for access control. So this sounds complicated, but essentially it means it's a tool that allows you to define who gets access to your encrypted data in a decentralized manner. Why do we need Seal? So before Seal, you can encrypt your data and put them on chain or on Walrus. But sharing this decryption key introduces additional security concerns. So what Seal allows you to do is manage this decryption process in a generic manner by simply defining what criteria need to be fulfilled on chain. So Seal splits this secret into fragments during encryption, and it will gather the key fragments behind the scene once the protocol confirms that the criteria are fulfilled. So Seal consists of 2 parts, as we discussed before. The on-chain access control policy, which are defined in Move, and the off-chain seal servers. So they are the ones that verify the access control by dry running the transactions. So if the verification is successful, the key server will send you a fragment of the decryption key to the sender that actually requested this particular secret key. So how does it all work exactly? So interacting with Seal mainly involves two functions. You either encrypt or decrypt, and both of these actions happen on the client side. So user first generates a base key, and Seal then splits this key into multiple parts. So each key server will hold a piece of this public key that a user will then use to encrypt each base key pair. So you're using these Seal key servers public key to encrypt a share of your secret key, right? So these key server can randomly generate. So the key server can randomly generate. Sorry, it's not randomly. They will only generate a decryption key if the criteria defined in the access policy are met. So the content creators can then store these encrypted key shares however they want, right? So and the next part is, so when we derive, so we then derive another key from this base key, which we kind of split into different pieces and then encrypt it with the key server's public key. So we use this base key to derive a key to actually encrypt our data. So the encrypted data can then be stored on Walrus or on anywhere else. So it's not really completely dependent on Walrus, to say. So let's jump right into a demo so we can see how this encryption works, right? So we'll demo the process first, and then we'll show you the code. So let me stop sharing here, and let me share my entire screen so you can see it. Yes, can people see this? So this is an example app that is in the Seal repo. So the code is available here. Let me also zoom in here a little bit. So the code is available here. I'm just gonna go to show you guys, right? So this is the examples under Miston Labs /Seal. So this is on GitHub as well. You can kind of just go in there, go to the examples here directory, and you'll be able to see what we're doing here. So we go back. I've already created so I guess what you will do is it will present you with two options, two examples. One is the allow list, the other one is subscription. So what it means is that we define our on-chain access policy in the way that only if you pay the content creator a fee, then you'll be able to access the actual underlying data. So if we go back to our to the actual code here, I think if you go to Move resources, so this is a subscription Move contract. So this is defined in contract. So the access control policy, this part is defined in Move. So we search for Seal approve. So in here you will see it has an approve internal function, which means that only if you have a subscription object, we will then be able to release that fragment of the key pair. So let's see how it works by encrypting some files. So I'm going to go back here. I'm going to encrypt some files. See if I can do that. Yes. See if I can upload this one image first. So we're going to encrypt and upload to Walrus. So this is using the publisher API since the file is fairly small. So We can also inspect this. Actually, we don't have to do that. We can just click on this. So the encrypted blob is here. So I just downloaded it, right? The SUI object here itself. This is the underlying SUI object. So you can see it's created 20 seconds ago. This is the encrypted. This is the encrypted file that has been encrypted by Seal, right? And then let's also upload another one. Actually, let's associate the file to a SUI object, which means that it's associating this SUI object, which is a representation of this encrypted file on Walrus. We're basically attaching this thing to our access policy so that if you are part of this access policy, if you fulfill the criteria, then you'll be able to access this particular file. So here I need to sign a transaction and then you can see what it's actually doing here. So we go to the transaction page. You can see that it is calling this publish function here. And I'm going to approve this. I'm going to then go back to here. So this is the underlying function here. It's basically adding this blob ID to the actual access policy as a dynamic field. So let's go back to our file. Let's upload another one. And then we can encrypt this again. So we do the same thing, right? So we're associating this this other image to this access policy, and then we'll hit approve here. And that's it, right? So we have thus added 2 images to this access policy that we have. And we can then take a look at the code, the underlying code here. So how is it actually encrypting things? So let's go to our front end, go to our source, go to encrypt and upload. So this is the actual Walrus upload thing. So basically I'm using the example app uses the CO SDK here that has been imported. And all you need to do is initiate this CO client. And in here, it will call this encrypt function. And to do that, you will basically supply the package ID, which defines this particular access policy. And keep in mind that each access policy, each package that you define here, they need to have this CO underscore approve function. So that's what the CO key servers will be looking for. And we'll talk a little bit about that later. And this is basically how you encrypt the file, is that you supply your package ID, which has this custom CO approve function. And then you also supply some kind of identity that allow the identity for the file that you actually want to encrypt. So that way you can find these different files, different policies more easily. And then what you, after you encrypt the file, you basically store this encrypted file as the blob on Walrus. That's what the example app is doing here, right? So every time I click, remember when I click the encrypt and upload to Walrus, it's basically doing this. It's going to handle submit function here. And it's basically encrypting the file with seal and then uploading that to Walrus. So that's the encryption part. Any questions we have here? Let's take a look at the question side. Okay, no questions. Let's go back to the presentation. So as I said before, this example is publicly available on github.com/mistinlab/co. Okay. So the next thing to do is to decrypt this file. So here's how it works on the decryption side. Or you can pause the video later and then kind of look at how exactly it's doing. But what it's doing is when a user needs to fetch the encrypted blob from sorry, a user first needs to fetch this encrypted blob from Walrus or any storage media that you're storing this file at. The user then signs a request for encryption keys to the key servers, right, attesting that they have the ownership of the wallet address, and thus the ownership over all of the objects tied to that particular address. So this happens on the client side and doesn't actually need any on-chain transactions. So the user only needs to sign this every 10 minutes or so, depending on the session, right? So which makes multiple which makes retrieving multiple decryption keys more efficient, right? So if you have if you have multiple files that you want to retrieve, you only need to sign this signature once. So the client also creates a PTB that calls the seal approve function, which we showed earlier, defining the access policy package. So this PTB, along with the signature, are then submitted to a key server, and then this CO key server dry runs the PTB by looking at the current state that it can observe. So it performs the verification, and if everything checks out, it effectively returns a decryption key that allow the client to decrypt the encrypted key share that the content creator encrypted earlier, right? So this allows basically the content creator to eliminate the need to share the secret key, right? The content creator instead would just add you to some kind of access control policy, right? So the content creator doesn't need to manage this secret key anymore. It only needs to manage the policy. So that's what the CO is actually doing. Recall the threshold we set during the encryption. So this is also part of the thing that I can show you guys later, which is this: during the encryption process, you can specify how many CO key server needs to sign the particular needs to approve your access control in order for you to actually reconstruct back this secret key that the content creator originally used to encrypt the file. So once the enough key shares are obtained and decrypted from various key servers, the client can then, so in this case, the browser would then be able to recover this symmetric key that was used to encrypt the data in the first place. So what you'll actually end up seeing is basically a pop-up saying, sign the signature proving you are who you are, and also proving that you are part of this access control package, that you have access to it, right? So without further ado, let's take a look at the decryption process. So let's let me stop sharing here and share my entire screen so you guys can see this. So we're back at the demo app, right? It says share this link with other users to subscribe to this service and access this file. So I'm going to click on this link. Basically, to access the file, this is how the policy was defined, right? I need to basically pay a certain amount of sui in order to view the content of the file. So I'm going to subscribe with 1,000 MIST, which is very, very small amount. In this case, it's just for demo purpose. In real life, you might need to tweak this the numbers here a little bit, right? So let's see what it's actually doing here. It is basically calling the transfer function here. So let's go take a look at this function, how it's defined, right? So in here, we have the example move. So we have the transfer function here. Actually, let's see. What is this calling? Oh, sorry. It's calling the subscribe function, and then it's transferring the. So the subscribe function basically is okay. So it gives a subscription object, right? So by what it's doing is that it's taking in a fee payment, and it transfers this particular coin to the actual content creator, right? This is what we said earlier, and then it will release this subscription object. It will basically issue this subscription object to the subscriber, which then grants you access to this access policy. So then in this PTB, we then transfer the subscription object to our wallet. So let's hit approve here. So now you see that the button changed states here, and we can go over the code there later. And then I'm going to just click on download and decrypt all the files here. So remember earlier that we only need to sign we only need to sign this signature, right? We don't actually need to do any kind of on-chain stuff here, because once we subscribe to the access policy, that's the end of the on-chain interaction. So the key server is going to dry run this and confirm that we are who we are and we have access to this particular access policy. So let me sign this. And I think I should be able to see two images here. There it is. There we go. We have the KEKW image, as well as the a meme from Star Wars. So that's kind of the decryption process in the demo. But let's take a look at the code here, right? So here I have the code of when it's actually being generated. So when it's actually doing. So remember, what we did was when we click on the file, we download and decrypted all the files, right? So remember, download and decrypt all the files. This is kind of where that particular button is at. And what it's doing is it's calling this onView function. And inside this onView function, if there's no subscription ID, it's going to handle it's going to handle the subscription. If you do have a subscription, it's basically going to construct a move call with the package ID, which we talked about earlier, and the access policy ID and the subscription ID. So this is the PTB that the client side, the browser, is constructing, and then it's going to then call this. It's going to call this download and decrypt function. Let's see what it's actually doing here in the download and decrypt function. So it downloads all the files in parallel from the aggregator, right? That's what it's doing. It's it's basically going to the Walrus aggregator and downloading the files, the encrypted version, right? And it will fetch keys from the key servers by constructing this PTB here. And once the PTB is constructed, it then calls this fetch keys function. And this is cached. So the decrypted fragments of the original keys are basically downloaded from the key server by also providing basically by also providing a proof that you actually own the address that is described on chain, right? And then eventually you piece together, once you have enough fragments, you can construct this original symmetric key. So what we need to do here is basically decrypt it by calling the sealClient.decrypt function here. And that's kind of what we saw earlier, is that when we call the decrypt, when we press the button to decrypt it, it will decrypt the images that we uploaded earlier. So any questions there? Let me take a look at the chat. Any questions? Oh, okay, no questions. Well, let's go to our presentation. Okay, so how do you use seal? So this we have talked about this thing quite extensively, right? In the sense that you need to define your access policy package with this this function signature called entry function seal underscore approve. And seal underscore approve is just the prefix, right? So you just need to make sure that you can have multiple seal approve function defined in the same access package as long as they start with seal underscore approve. So you can use your seal SDK on your front end to decrypt, to encrypt with the public keys from the key servers, and also define the threshold that you want the policy to actually gather, right? You can fetch key shares, these decrypt the key shares from the key servers, and then finally you would call this seal client decrypt function, which with the assembled private key for the given identity, which is the file or the access policy, then you'll be able to decrypt whatever is under this access policy. So I will also link this. I will link the presentation so you guys can check it out. So the next thing to mention is basically how to use seal to encrypt large files. So currently, if you are using seal to directly encrypt the files that's larger than, I would say, 60 megabytes, it could take a long time. So the best security practice for that is actually to encrypt the file with a random passphrase, right? And then you use seal to encrypt this random passphrase. So then you have a layered encryption scheme. So I'll show you guys a little bit later as well. So the diagram there kind of shows you how to do that. You're basically uploading an encrypted version of the file on Walrus, but you're also uploading an encrypted version of the secret key somewhere else, right? It could be Walrus, it could be anywhere else. So then the decryption process is you would use seal to decrypt this random key. And then with this random key, you can then decrypt the file that is uploaded to Walrus or some other storage media. So let's show you guys how that works. Let me share my entire screen. So I have here a sample file that has about 700 megabytes, and this is just a plain text. So tail sample. So this is just plain text file that's just randomly generated, right? And say that I want to encrypt this file. Here, I'll show you guys how this script is doing here. So what it's doing is that it's generating a random passphrase using OpenSSL, and then it uses the GPG AES-256 encryption algorithm to encrypt this file with the passphrase. And the output of it will be just called encrypted.gpg, right? So let's actually run this. So it's going to take a while. It's 700 megabytes. Okay, so now the file has encrypted, has been encrypted. So the passphrase is saved to this passphrase file. So you can then basically, let's see what it is. So this passphrase here, right, only has 45 bytes, and you can easily just use seal to encrypt this 45 bytes file instead of encrypting the 700 megabytes file, right? That's kind of what the layered encryption means. That you would then upload this encrypted version of the file separately, and you will obtain this encrypted version separately from your this passphrase that is actually holds the secret key. So, any questions there? Let's see here if we have any questions. Okay, no questions. Go back to our presentation here. What can you build with Seal? Basically, you can build anything. So because Seal is an access control policy manager, you can effectively build anything that deals with access. So content creation, content subscription, secure messaging, secure voting with time lock, games with some kind of states that you want to reveal, or any kind of token gated access. So basically, a good example of it is this messaging SDK that we have. So the messaging SDK allows you to securely message people between different using your wallet itself, right? So the Sui smart contract, basically the messaging SDK uses Sui, which uses a smart contract to manage the channels, the messages, membership, and the encrypted message store. Walrus to store all of the encrypted message, as well as Seal to basically encrypt the message themselves with the attachment, and also the programmable access policies that we have talked about earlier. What's the next step? So the third workshop leading up to the Walrus Haulout Hackathon is going to have topics about Nautilus, which basically allows you to verify off-chain compute on Sui. So these off-chain compute are basically done by a trusted execution environment, and it will generate a receipt, and you can use this receipt to prove on Sui that you have executed something off-chain correctly. So for any further questions, please refer to the docs here, co-docs.wall.app. I think, Amog, if you can pin the banner to the stream, people can see that, as well as a couple other resources that you can use to ask for help. So that concludes today's workshop. And let's see if we have any questions here. Questions, guys? No? Okay, I'm going to give like 2 more minutes for questions. Yep. Thank you for tuning in. See the chats. See any other chats here. Okay, no questions. We're gonna wait for another minute. Questions, guys? Questions? Anything? Okay, very shy crowd today. Okay, I think that's everything. There's seems to have no questions for today's presentation, so I think we can end our stream there. Yeah, so I guess if you have any questions these are the resources there that you can kind of get help or read more about what we just talked about. So go play with the example app and let us know if you have anything that you wanted to know. Okay, cool. Let's end the stream right here. See you in the third one.